Hello students, welcome to another video of bioinformatics series. In this video, I'll be discussing why PAM matrices are linked with BLAST tool while calculating local alignment between two sequences. So let's start. To understand why they are linked, let me show you an example. Suppose we have two sequences, sequence 1 and sequence 2, and if we give a score of +1 to match and 0 to mismatch, then we can generate two alignment having a score of 5 and 6 respectively. So which one is the best alignment out of this? The alignment which is giving the maximum score is the best score, but there are certain situations when this criteria of giving of selecting the alignment which is giving the best score or the highest score as the perfect alignment doesn't do justice. What are those situations? Let me show you. There are certain situations where the amino acid, let's suppose this is a protein molecule and this is a amino acid, and if suppose this is amino acid is methionine, and let's suppose this amino acid is methionine. So if this methionine is being substituted by leucine, then the hydrophobic interaction does not alters. Why? Because the chemical properties of methionine is almost similar to leucine. But what happens when methionine is being substituted by arginine? The hydrophobic properties or the hydrophobic interaction differs because arginine is a charged amino acid. So what I want to say here is, if the two amino acids which is being changed during the course of evolution or which are being mutated during the course of evolution, they must be having same chemical properties. If not so, then the BLAST algorithm or the BLAST tool doesn't do justice with finding the best local alignment. So due to this reason, the PAM matrix has been generated, which gives us the probability of two amino acid being mutated, or one amino acid is being mutated to another amino acid during the course of evolution. The PAM matrix, how to create a PAM matrix, I have already told you in my previous video. So in this video, I'll just be discussing how the BLAST tool and PAM matrix has been linked. So they are linked because BLAST tool doesn't do justice in this situation where the amino acid which is being substituted is not of similar chemical nature to the amino acid at which place it is being substituted. Now let me show you where is that option available on the NCBI portal. So this is the web page of NCBI where we can do BLAST P or protein BLAST. At this point we already know that this is the point where we have to put the FASTA sequence of the protein for which we want to do BLAST analysis. Now let's come directly to the option where we can change the option of BLAST matrix, or we can select the matrix which is to be used during the local alignment. If you go into the algorithm parameters at this position, then you can see scoring parameters and you can see a subheading matrix. Here you can select matrix from PAM to BLOSUM and different values of PAM and different values of BLOSUM. So this is the place where we can select different matrices depending upon our need. So in this video, my aim was just to show you, or just to make the student understand why the PAM matrix alone is not sufficient and why the BLAST tool alone is not sufficient to create a local alignment, and why they are linked to find the best local alignment. So I hope I have done justice with this video. See you in the next video. Thank you. Okay, bye bye.